The next question of CodeChef Starters 117 is spread spree.
This question, spread spree, says it's about a grid. Okay, a grid where will be given a grid, will not be given a grid, will be given n,
Yeah.
which is the size of the grid. Nm is the size of the grid. And let's discuss the question. Let's discuss what exactly the question is for, because that's where we'll know what exactly we'll do. Let's say in this entire m cross m grid, there is one index I comma j. There is one index or one cell I comma j, which is first. Let's say all the cells of nm. Why is it getting so quick? All the indexes are white, or all the cells are white, and there will be one index ij that we can select, and will and we can paint it black. Okay, after we paint any one cell as black, what it will do is it will start spreading its black color to all of its neighboring cells.
Yeah.
And neighboring cell in the sense only four things: top, down, bottom, and right.
Yeah.
Let's take an example to understand it clearly what exactly we mean by spreading and coloring the cells. Let's say so as I was saying, if you take an example, n equal to 4 and m equal to 5. N equal to 5 and m equal to 6, which is number of rows and columns.
Yeah.
And if we assume ij to be this cell,
Yeah.
okay, ij to be this cell, we'll paint this as black.
Yeah.
It is yellow for now. Let's assume it is black. Or we can change it to black also. Okay, we change it to black. Now, what this cell will do is it will spread its black color to all of its neighboring cells. All of its neighboring cells, in the sense, all of its cells which share a common edge. All the cells which I marked green.
Yeah.
All of this will be spreaded by this cell.
Yeah.
And it will be black. And in the first second, if you talk regarding seconds, in the first second, cell 2 comma 4,
yeah,
made all of its neighboring cells black, which
yeah,
we just now saw. Now all these cells which were black, which were made by 2 comma 4 cell black, they'll start making all other cells, all of its other neighbor cells as black.
Yeah.
All of its neighbor in the sense these cells which I'm marking as black.
Yeah.
So after this, on the second,
yeah,
all other outer cells, all other neighboring cells again became black. And the third second, entire grid will become black.
Yeah.
Correct? The second, and the third second. So total 3 seconds were required from a cell ij. In our case, ij was 2 comma 4.
Yeah.
Total 3 seconds were required to spread the black color to entire grid. Yeah. Let's see in a better visualization what exactly just now happened. If we assume ij, to be 3 comma 4. Let's see what happens in this case. The first cell which we took as 3 comma 4 in the animation, now it will come. Now it's first black, it spread to its neighbor, it spread to its neighbor, and again at the neighbor. So total seconds required, you can say 3. So last example which we discussed, we took cell as 2 comma 4, and this example we took 3 comma 4. These two cells made entire grid black in 3 seconds.
Yeah.
So for m equal to 5 and m equal to 6, n equal to 5 and m equal to 6, we saw these two cells took 3 seconds of time to make entire grid as black color.
Yeah.
So now the question is clear. You can say 3 is the number of seconds. Now, what question is asking us is, if there are multiple such indexes, you have to return sum of the product of the indexes.
Yeah.
In this case, till now we found 2 indexes, right? So till now, answer is 2 into 4 plus 3 into 4.
Yeah.
Okay, but there can be many indexes. While multiplying, you have to return all the sum of product of the indexes while modding with the given value.
Yeah.
And the given mod value is 998,244,353. Just to make sure answer doesn't goes out of limit. So now, if we visualize the same n equal to 5 and n equal to 16 from a cell I comma j. How much time it will take? How many seconds it will take to make entire grid as black? Let's see. So this is the second step.
Yeah.
All these indexes which we just now saw, these cells
Yeah.
will
They
take 3
minimum.
seconds. Correct. You can try it by your own. For now, what all we discussed is 2 comma 4 and 3 comma 4.
Yeah.
We saw these two will take 3 seconds. You can check by yourself. Like all these indexes will take 3 seconds of time.
Yeah.
All the indexes which I'm marking as green will take 4 seconds of time. And all the indexes which I'm marking as this color will take 5 seconds of time.
Yeah.
So out of all this, if I ask you what are the indexes which took the least time, you'll say all these, right?
Yeah.
So now product of indexes of sum of product of all these indexes will be the answer.
Yeah.
So for this indexes 2 into 3 plus for
2
this
into
3 indexes 2 into 4 plus for this 3 indexes 3 into 3
plus 3
plus 3 into 4 plus 4 into 3 plus 4 into 4. This will be our answer. Of course, we have to mod it at every step such that answer never exceeds the limit.
Yeah.
So this is the question. The question was a bit tricky. Answer will be pretty simple. Let's see what can be the solution.
So in this question, the constraints are T will lie in the range 1 to 10 power 5, right? And N and M will lie in the range 1 to 10 power 1. So if you guys see, you guys might have gotten the thought to do BFS, as this is just like a BFS, but constraints aren't allowing us to do a BFS. Like if we do BFS for every fixed cell, we need to perform BFS, calculate the minimum time, and for all the cells which took minimum time, we can just sum up their product of indices. But that is not allowed, as it takes any time if you do BFS, and that too for every cell we are doing. So it takes
N into
every fixed n into m whole square. Correct? So now we need to optimize it. Looking at the constraints, it says that there is no dependency on n and m. So it says that we need to come up with some logic which is almost constant. So let's see how we can solve it in constant. So to solve this problem, firstly, let's analyze one thing. Let's say I, J are given, right? J. So the grid is of size n comma m, right? And in this grid, let's say we know we are given some ij. Now, if ij is colored black, then what is the minimum time required to color whole grid? Can we say it is nothing but max of I minus 1? Consider I and j as one base, as mentioned. This is nothing but the distance from I to the left, I to the top, j to the left, I then from I to the bottom distance, that is nothing but n minus 1, m minus j, right? These are the this will be the minimum time required to color this will be the time required to color every cell from I comma j, right? So from this, what can we observe? From this, the claim is time will be minimum time will always be maximum of n comma m by 2, right? Floor part of this, right? You can just look over this formula because we are considering max among the left, top, bottom, and right. It is beneficial for us to place the index in middle, right? In between the largest side. If n is larger, then it's optimal to place it at the middle row, and if m is larger, it's optimal to place it at middle column, right? Middle column, and in the column we need to decide till which row or till which column we can place it. So let's see how we can calculate that. So for now from this we just observed the minimum time required will for sure be max of n comma m by 2. Right? Now let's solve this problem for two different cases. If n is greater than, right, then we know the minimum time required is floor part of n by 2. Right? This is what we know. Now let us consider the. Now in this also we have two cases. If n is odd, right? Firstly, let's solve for odd. So let us take a grid just to dry run that. So here, if we look over, let's take columns as 4. So here columns are 4 and rows are 5, right? Now the claim is minimum time that we need is n by 2. That means from at which cell should we place? Because here n is greater. Can I say we need to place it? Okay, let's not see where to place. Firstly, we know that in this row, some cells in this row will give us the minimum answer, right? But we can't say all cells in this row will give us the minimum answer. But now what we segregated is we can just ignore all these rows. This is what we just noticed. Because if you observe, putting cell in any of this row will actually increase our minimum time. So we can ignore all these rows. Now in this yellow shaded part, which can be our row, and the row number is nothing but seal of n by 2. Right? The row number of this is seal of n by 2. Now in this row, the claim is from certain L to R, all those cells will give us the minimum value. And let's find out what is that L to R. So firstly, we need to know L and we need to know R. So the claim is L to R should be, if we consider the Lth point, then L to the last cell should have a distance of less than or equal to n by 2, right? To the last cell. Similarly, for R, from 1 to R, the distance should be less than or equal to n by 2. Right? So we should pick such a R and such a L. Then we can say everything in between L to R, we can always color. And here, for sure, L will be less than R all the time. Why? Because L will be either less than or equal to R all the time. That is because n by 2, n is greater than m, right? So for sure we can say n by 2 will be greater than m by 2. So that is the reason why L will always be less than m. Because from here if we calculate L, then it will come somewhere in between in between 1 to m by 2. And from here if we calculate rth point, that will come in between m and m by 2, right? For sure. So that is the reason we can say L is always less than or equal to. So in the case of 5 cross 5 grid, we can see L and R will come exactly to the middle. Right? So that means L and R are equal. So now let's see which L and which R satisfy. In this case, if we manually look over, this L and this R will, from this cell to this R, all the cells will give us the best answer, right? These cells. So let's see how to calculate that. So in this scenario, L will be, can I say L is nothing but minimum of 1 comma, why 1 in the sense grid columns, the width of the grid can be very small. It can be smaller than n by 2. Then we can't take cells which are not present. So that is why it should be minimum of n by 2, comma uh, m minus the delta. So delta here is floor part of n by 2. This can be our L, and R is max of m, comma floor part of n by 2 plus 1. Right? This is the value. Now you guys can verify this also. Why it is m minus n by 2 in the sense this cell towards the border, we can see the distance is just n by 2, right? So from this cell, if we see distance is n by 2, which is 2 over here. Similarly, from R cell towards the front, we can see it's n by 2. And we can't extend R or extend L because more than n by 2. So that is why this will be our L and R values. Now, if we see, the answer would be L into the row number, right? Which is seal of n by 2. So I'll just mention seal as follows. This is the seal, right? N by 2. Seal of n by 2 plus this is the symbol of seal, rounding up, n plus 1. Seal of n by 2 plus so on plus r into seal of n by 2. Right? This is what we'll get. So from this we can say seal of n by 2 into L plus 1 so on plus r will be the answer. Right? Now we can't iterate a loop and calculate this, but we can just observe that this is just natural. These are just natural numbers starting from L. So we can write it as we can just make this a O1 formula. That is, we can write it as r into r plus 1 by 2 minus L into L minus 1 by 2, right? So in the case of odd, this is how we can solve. Just calculate the, because in the case of odd, the middle row will only be 1. So that is why this is the value. Now let's take a even case. 0. If n is even, then we can see that the grid looks as follows. Let's take a 4 cross. This is a 6 cross 4 grid. So here let's see what will be. Let's index it one base. Right. So now over here, what will be the smallest time possible? The claim is it will be floor part of n by 2. Right? So here floor part of n by 2 is nothing but 3. So can we say that these two are the middle cells? Right? Yes. These two are the middle cells. So in these two, again we can observe that there will be some L to R limit. L is over L can be somewhere like this, and R can end somewhere over. Right? So in this case, we can observe that L comes over here, R is over. Whole grid will satisfy. And here also to calculate L and R, it is similar to how we did for R. Left point will be, and everything holds as n by n is greater than m. L should be somewhere in the range 1 to m by 2, and R should be in the range m by 2 to n, right? So now L is maximum of 1 comma m minus floor part of n by 2. Right? Here also. So here we need not take floor part, as it's even, it will be divisible. Right? So though we write it as floor, it doesn't affect. R will be minimum of m comma floor part of n by 2 plus 1. Right? So these are the L and R limits. Now we can observe that. Now what is the value of this? Can we say the value is nothing but n by 2, as it is even here? N is perfectly divisible by 2. So we can say n by 2 into L plus n by 2 into R into L plus 1, so on, plus n by 2 into R. Right? And this is the middle number. N by 2 is our middle number. Now the next middle number would be n by 2 plus 1. Right? Into L plus so on plus n by 2 plus 1 into R. Right? So if we combine both of them, we can observe that we'll get n by 2 plus n by 2 plus 1 into L plus so on plus R. Right? So we can write it as n plus 1 into R into R plus 1 by 2. L into L minus 1 by 2. Right? Can we write it like this? So we can write it like this, and this is how we can formulate for n even. If n is greater than m and n is greater than m and n is even, then this is the case. If n is odd, then previous one was the case. Right? That is over here. And ensure that while performing this, you use modulo in such a way that answer won't overflow. Right? Now, if n is greater than m, this is done. Now tell me if m is greater than n. In the case of m is greater than n, whatever we formulated, in that just replace n with m and m with n.
Or you can, in this formula itself, can we just swap m and n values?
Yeah. Or what we can do is we can just swap m and n values.
And how we are saying this is,
We can always rotate the grid.
correct.
So swapping n and m is nothing but rotating the grid. So if we look over, one way is do the exact same thing for m and n. Do the exact same thing for the scenario m greater than n also. Or to shorten your code, you can just consider that you're rotating the grid, because let's say this is our grid. Right? Yeah. So let us,
Okay, if this was our grid.
yeah, if this was our grid, then what happens is, let's say for this grid, answer is x. Right? Okay, let's name it as answer only. It has some answer. Then my claim is, though we rotate the grid, it doesn't affect our answer. Right?
Correct.
So if you rotate this grid, you'll get a 4 cross 5 grid. Right? This is a 5 cross 4. You'll get a 4 cross 4. So all rotations of this grid will also have the same value. So that is why we can just do the same. Yeah, if you rotate it like this, you can see that it's 4 cross 5. And in this scenario, it is, previously rows were 5. Now, if you see, so this was the this was the rotation, right? And look the same thing from your left, then you can observe the other rotation.
Correct.
So Basically, the point is if you rotate the same grid, then for all the rotations you'll get the same answer. So, so that is why you can just consider if n is greater than m, we did this the following thing. Right? So if m is greater than n, you can just swap n comma m, right, with m and n. So now n and m are interchanged. That means you are solving the problem for a rotated configuration. So no matter how you solve, because rotated configuration and the normal grid has the same answer. That's what we just saw. So so instead of replicating the same part for n greater than m and m greater than n, you can do this universal for both. And in case if m is greater than n, just swap n and m. Then it works, right? So this way we can solve the problem, and this is the derived formulas for each and every case. So if you look at the time complexity, it is big of 1, and space complexity is also big of 1 per distance. So this way we can solve it.